Okay, hello everyone. Today we're going to be talking about quality assurance in the dental office, and this is on chapter 10 in your dental radiography textbook. So we'll first go over the learning objectives of this chapter. As always, we'll define the key terms associated with quality assurance in the dental office. We'll list quality control tests and quality administration procedures that should be included in the dental assurance plan. Discuss the purpose and frequency of testing dental x-ray machines. We'll describe the tests used to check for fresh film and adequate screen to film contact, and discuss the frequency of testing and the interpretation of test results. We'll describe the tests used to check for darkroom light leaks and proper safe lighting. Also discuss the frequency of testing and the interpretation of the test results. We'll describe the test used to check the automatic processor, as well as discuss the frequency of testing and the interpretation of the results. We'll use these three tests to these three tests are used to check the strength of the developer solution. We'll describe the preparation of the reference radiograph and the standard step wedge radiograph. We'll discuss the use of these radiographs to compare densities and to monitor the strength of the developer solution. We'll describe the tests used to check the strength of the fixture, also discuss the frequency of testing and the interpretation of those results. We'll discuss quality control tests needed for digital imaging procedures, and we'll discuss the basic elements of a quality administration program. Also, detail the importance of operator competence in dental radiographic procedures. So quality assurance refers to special procedures that are used to ensure the production of high quality diagnostic image. And the purpose of all of this is to introduce the radiographer, you, to quality control tests that are used to monitor dental x-ray equipment, supplies, and film processing. So although the dentist is responsible for ensuring that these things are done, the tasks themselves are typically left for the dental radiographers. To avoid excess exposure of patients and personnel to X-radiation, the dental radiographer must have a clear understanding of the quality control procedures used to test X-ray units, supply film, film processing, and digital imaging equipment in the dental office. Quality control tests are necessary to monitor all the dental X-ray machines, film, screens and cassettes, and viewing equipment. Everything must be in good working order to produce diagnostic radiographs. This includes the dental x-ray machines, the film, the screens and cassette, as well as the viewing equipment. So all the dental x-ray machines must be inspected and monitored periodically. They also must be calibrated on regular intervals. And it is the American Academy of Oral and Maxillofacial Radiology that recommends a number of annual tests for dental x-ray machines. So local and state regulatory agencies provide the inspection services, but it's the ones that use the x-ray equipment, such as the hygienists, dental assistants, and some manufacturer service representatives that can actually perform the annual tests. Each box of film should be checked for freshness before it is used. And to do this, you will first prepare your film by unwrapping one exposed film from a newly opened box. Next, you'll process that film using fresh chemicals. If the film appears clear with a slight blue tint, then the film is fresh and has been properly stored and protected. Then we can go ahead and proceed with the use of the film. If that film has expired or has been improperly stored or has been exposed to radiation, it might appear fogged. And if the film is fogged, it should not be used. We should use that whole box is probably done, and we should probably use a new box. So extraoral intensifying screens are used with the cassette holder and should be periodically examined for the presence of any dirt and scratches. Screens should be cleaned on a monthly basis with commercially available cleaners recommended by the screen manufacturer. And cassette holders must be examined every month for worn closures, light leaks, and warping, all of which may result in fogged and blurred images. A commercially available cleaner should be the only type of cleaner used on the screens, and an anti-static solution should be the only type of cleaner used on the screens after, or an anti-static solution should be applied to the screens after they have been cleaned. So the exposed film will either be of adequate contact or inadequate contact, meaning the density that is exhibited. And in order to check for the contact, we can do a contact test. So to do this, we'll first insert a film into the cassette holder, and then we'll place a wire mesh on top of the loaded cassette. And we'll position the PID with a 40-inch target film distance, and we'll set it so that it's at a perpendicular angle to the film. Then we'll expose the film using 10 MA, 7 kVp, and 15 impulses, which is about 0.25 seconds. Then we'll process the film, and we'll view the film on a view box in a dimly lit room at a distance of 6 feet. If there is adequate contact, the wire mesh image is seen on the film, and it exhibits a uniform density. Good screen film contact has taken place. If that's the case, we can go ahead and proceed with the cassette and screen use. If it's of inadequate contact, the wire mesh image seen on the film will exhibit varying densities. Poor screen film contact has taken place in this case. If that's the case, cassettes that provide inadequate screen film contact should be repaired or replaced. So for the viewing equipment, a view box is basically just a light source used to view dental radiographs. So with this type of equipment, we'll also want to clean it regularly. The plexiglass on the view box, the plexiglass on the view box should be wiped and cleaned daily. And it should reflect a uniform and subdued light. If it doesn't, then the bulbs or the plexiglass might need to be replaced. Also, scratched plexiglass or dim bulbs will make the radiographs hard to read. So if that's the case, they should also be changed. All right, so then we're going to go on to film processing. And this is one of the most critical areas in quality control, and it requires daily monitoring. And we'll want to check for darkroom lighting, want to check the processing equipment, as well as the processing solutions. So darkroom lighting must be checked for light tightness every month and for proper safe lighting every 6 months. And to do this, or to check for this, we'll want to first prepare the darkroom. We'll do this by closing the darkroom door and turning off all the lights, including the safe light. Next, we'll examine the darkroom. So once your eyes become adjusted to the dark, you'll want to observe areas around the door to check for any leaks. So if you have no light leaks, we can go ahead and proceed with film processing. If we see any light leaks, they'll probably be from the seams of the walls, the ceilings, or through the vents, or even the keyhole. If we see these types of things, we'll want to correct these either with weather stripping or black tape. Safe lighting is something that we use in the dark room to allow us with enough light to work, but it should be dim enough so that it doesn't expose or ruin the film. So to check for this, we'll do something called a coin test. So we'll first prepare the dark room. So we'll turn off all the lights of the dark room, including the safe light. Next, we'll prepare the film by unwrapping one exposed film and placing it on a flat surface at least 4 feet from the safe light. Then place the coin on top of the film. So like a penny or a nickel or something like that. Then we'll turn on the safe light and allow the film and the coin to be exposed to the safe light for about 3 to 4 minutes. Then we'll go ahead and process the film. Remove the coin first and then process the film. If the image appears fogged, the safe light is not safe to use with that type of film. If no visible image is seen on the processed film, the safe light is correct and we can go ahead with film processing. The processing equipment includes, so like for an automatic processor, we'll also need to test the film for that. So we'll do this by first preparing the films by unwrapping 2 exposed films and exposing 1 to light. We'll then process both films in the automatic processor. The processing equipment must be meticulously maintained and monitored daily. This includes temperature, levels of water, levels of the developer, and your fixer solutions must also be monitored. So next we'll talk about the processing solutions. So these should be replenished daily and changed every 3 to 4 weeks or every month. And we'll check for developer strength by using the reference radiograph, a step wedge radiograph, and a normalizing device. A reference radiograph is something that is processed under ideal conditions and then used to compare the film densities of the radiographs that are processed daily. And to test for this, we'll use, in order to take one of these, the first thing that we'll do is prepare the film. We'll use a fresh film to make a reference radiograph, and we'll place an aluminum step wedge on top of that film. Then we'll expose the film using the correct exposure factors, and then we'll process the film using fresh chemicals and at the recommended time and temperature. If the density seen on the reference radiograph match the density seen on the daily radiographs, the developer solution strength is adequate and you can go ahead and process your films. If the density seen on the daily radiographs appear lighter than those seen on the reference radiograph, the developer solution is either weak or cold. And if the density seen on the daily radiograph appear darker than those seen on the reference radiograph, the developer solution is either too concentrated or too warm. Weakened or concentrated developer solution must be replaced if that's the case. And if the developer solution is too cool or too warm, the temperature must be adjusted. A step wedge radiograph, so we'll have a device with the layered aluminum steps, which is your step wedge. And in order to take a step wedge radiograph, we'll first prepare the film. So we'll use a total of 20 fresh films to create a 1-month supply of the films for daily testing. So we'll place an aluminum step wedge on top of one film, and then we'll expose that film, and we'll repeat with the remaining films using the same step wedge, the same target to receptor distance, and the same exposure factors. And then using fresh chemicals, we'll process only one of the exposed films. This process radiograph is known as your standard step wedge radiograph. Then we'll store the remaining 19 films in a cool, dry area protected from X radiation. Every day after the chemicals have been replenished, we'll process one of the exposed step wedge films. So this is out of those 19 films that we used. This film is known as the daily radiograph. So we'll view the standard radiograph and the daily radiograph side by side on a view box. We'll compare the density seen on the daily radiograph with the density seen on the standard radiograph. So we'll use the middle density seen on the standard step wedge radiograph for comparison. If the density seen on the standard radiograph matches the density seen on the daily radiograph, the developer solution strength is adequate, and we can go ahead and process our films. If the density on the daily radiograph differs from that on the standard radiograph by more than 2 steps on the step wedge, the developer solution is depleted and should be changed before proceeding with your processing. So a normalizing device is a commercially available device that can be used to monitor developer strength and film density. As we discussed in chapter 9, the fixer solution removes the unexposed silver halide crystals on the film that results in clear areas on the processed dental image. When the fixer loses strength, the film takes a long time to clear or become transparent in those unexposed areas. And when the fixer solution is at full strength, the film should clear within about 2 minutes without agitation or without having to shake it. So we'll want to perform what's called a clearing test to check for this clearness. And to perform this clearing test, we'll first prepare our film by unwrapping one film and then immediately placing it in the fixer solution. And then we'll check the film for clearing by measuring the amount of time the film takes to clear. If the film clears in about 2 minutes, the fixer is of adequate strength and we can go ahead and process the film. If the film is not completely clear after 2 minutes, we'll want to re-immerse it in the fixer solution. And if it still doesn't clear after about 3 to 4 minutes, the fixer solution is depleted and we'll want to change it or replace it before proceeding with the processing. So digital imaging requires quality assurance protocols as well. And this will usually include performing backup of digital data on the computer on a daily basis so that we don't lose any of our previous patients' films. And we'll want to perform annual tests for calibration of imaging equipment. And there are commercial kits that are available for this. And these kits will include a set of test objects and allow for the following checks. So this will test erasure cycle efficiency, image retention, sensitivity, uniformity, scaling errors, blurring artifacts, and resolution. Quality administration refers to the management of the quality assurance plan in the dental office. And although many of the technical aspects of the quality assurance plan may be delegated to the dental radiographer, it's the dentist that is ultimately responsible for the overall quality assurance. The basic elements of a quality administration program include description of the plan, assignments of duties, monitoring schedule, maintenance schedule, record keeping log, plan for evaluating and revision, and in-service training. Now, a copy of this quality administration plan should be made available to all of the staff members in your office. Each staff member should participate in the quality assurance program. So there should be certain jobs that are delegated to you, and everybody kind of is cohesive in making sure that all of these things are being done and logged and recorded. So the dentist is ultimately responsible for the diagnostic quality of all dental images exposed in his or her office, regardless of who actually exposes these images. Therefore, the dentist relies on the competence of the dental radiographer. Each dental radiographer must be competent in exposure, processing, and imaging retrieval techniques. If the operator produces a non-diagnostic image, the image must be retaken. Because all retakes expose a patient to additional X radiation, the number of retakes must be kept to an absolute minimum. Operator errors that require retakes should be recorded, and the use of this log is to record retakes, which will aid in identifying recurrent problems that require attention. Certain people might need to be retrained, things like that. Continuing education courses or individualized instructions that can be useful to upgrade and improve the competence of the dental radiographer. So moral of the story is don't be an incompetent dental radiographer, be a competent one. All right, as always, if you have any questions, feel free to email me or ask me in class. Thanks for listening. We'll see you next time.